Check, check, check. We're good. All right. So I chose these problems for the bell work because everyone remembers this, right? The good old days. Well, even not that good because, man, I kind of hated fractions, right? But everyone, I think, has got a grasp on this. I think that everyone at this point has gotten to where they say, oh, common denominator is 6, right? And we skip a step altogether, whether you know it or not. What step do we skip? How do we get 6? We multiply. The easiest way to get this is to multiply your denominators. In this case, 2 times 3. Actually, I'll write it like this. Is that cool with you guys? So that's 2 times 3, just because I want you to see some of the notation that I'll be using today. Okay? So I got my denominator. I said, all right, there's my common denominator. It's my LCD, my least common denominator. Then you have to ask yourself the question, okay, how did 2 become 2 times 3? Obviously, it got multiplied by 3. Yeah? So if I do it to the bottom, what do I need to do? I got to do it up here. So this becomes 3 times 1. We don't really write 3 times 1. We just say, oh, that's just 3, correct? But I'm showing you some of the steps that we skip because we can do them in our head, right? Now, the other question is, how did this 3 become 2 times 3? We multiplied it by 2, which means we do it up here as well. So this is plus the 1 times 2, which is simply 2. That becomes 5, 6. Ugh. You see me trying to hold it up there? I was like, don't go yet, but I can't. Yesterday, it was all day. I thought I had allergies. I didn't tell anybody. Like, man, my allergies would kill me. They're not allergies. I have a cold. It's horrible.
I thought I saw your hair do a little flick there.
What happened?
I thought I saw your hair do a little flick.
It probably did.
His toupee.
My toupee. So this is the piece that I kind of want to emphasize today. We do that, and we do it in our heads without really thinking about it, because it kind of seems like too much work, right? Like we don't really need it. But today, well, we'll talk about it a little bit. Everyone cool with that, though? What we see up there? Let me see those thumbs up, thumbs down. I got this. I don't have this. Hey, qué gusto. Qué susto verte. What's up? Damn, come on. I'm a teacher, dude. I ain't got no money, honey. And you got to change for 10? So.
Gracias.
Sorry. So, let's look at the next example. The next example is a little bit different, right? Because there's 3 parts to this, and I want to make sure that I also get this thing called the LCD. And I know that, just like above, probably the fastest way to get it would be to go 3 times 5 times 6, correct? But is that really the LCD? We know that's not, and someone just tell me why. Why is that not the LCD? Nico, can you see past this? What?
30 is what?
Yeah, but how do we know that that's not it? You know that 30 is the one, right? So how do you get 30? Okay, see, here's a part where we kind of overlook. We don't really care too much. How did you get 30, for starters? Because, see, you're doing the math, but you just don't know you're doing the math. How did you get 30 as the LCD?
I just multiplied 5 times 6.
You just multiplied 5. You just multiplied the 5 and the 6. Why not the 3?
Because 3 times 10. Is it the biggest numbers?
Because 3 times 10?
No, because 3 times 10 is 30, so you got that. Oh, nice. Okay, so to do it all, to get 30 for the first one, you do 3 times 10, but just to get those, you would multiply by each other.
Okay. Let me clear up a little bit of what the rules say. Okay? That 6 is a composite number. You guys remember what a composite number is? It's something that, it's a number that gets multiplied by 2 numbers other than itself and 1. In this case, those numbers are 2 and 3. 2 times 3 gives me 6, doesn't it? And in order to get a least common denominator, all I'm taking is the common factors down here. 3 is represented here, and it's represented here. Do you see that? So do I really need to show it twice? if it's already represented once before? No. So once I go over here, the 6, and I should rewrite it as this. What I do is I take the factors of that, which is the 5, and I can take the factors of 6, which is 2 and 3. So there's my 5. This is my 6. Do I really need to represent 3 again if it's already in there? No, because 3 is a factor of the 6, so I don't need it. Now I have this thing called the LCD. Did that make sense a little bit? Somewhat? Let me see if it's a 5 on that one. 5 means, okay, I could teach somebody. 4 is I'm good. I got that. So I could teach that to somebody, okay. Oh, I got 10 over there. I was like, man, you're trying to take my job. I want you to. All right, so we're good with that, right? Now, do I need to finish the top part, or are you guys good? At this point, we're going to ask ourselves, okay, how did 3 become 5 times 2 times 3? Well, I'm going to multiply by how much?
10.
By 10. I do the same thing on top. 10 times 2 is 20. How does 5 become that? Well, I multiplied by 6. That means this gets multiplied by 6, so I've got a 24. And then how did 6 become 30? Well, I multiplied that by 5, so I do the same thing up top. And then I simplify that whole business, right? So I wanted to throw that in because that skill, that piece in the middle that we're talking about, we overlook it. And we really need it. Not just for today, but once we get to 8.6, which is solving equations with that. Okay? We're looking for an LCD. So let's get to it. Today we're working with simplifying rational expressions. This is 8.4, you're correct. So we're simplifying rational expressions. And I forgot to change the title on the video. I'm going to have to change the title later. This is not it. So our objective today is that you will understand that you can use much of what you know about multiplying and dividing fractions to multiply and divide rational expressions. You guys know what a synonym is? Did I say that right? Synonym? I always had trouble. I always would say synonym. A synonym is a word that means the same thing, right? Almost the same thing. What's a synonym for ratio? Did I say synonym again? Ah! A synonym of ratio is, starts with an F, ends with an action. Fractions. So that's what we're doing today. We're working with fractions. And they're not the nice fractions that we knew. But, you know what? I get that a lot. I told second hour. Back when I took calculus in the summer of '01. You know what people struggle with in calculus? Fractions. The fractions. It's always the fractions. Fractions become the F word in mathematics. Someone say fraction, be like, ooh. He said fraction. All right. So let's get to it. Simplifying rational expressions. Again, just like before, watch me do one. I don't think that there's going to be much that you don't know what's going to happen. Nothing's going to surprise you here because it's still following the same rules. Let me do it. Put your pencils down, and then once we're done, I'll let you copy all that you want. Okay. All right. So let's do this. Here's my first one. We want to simplify this, and then we want to talk about any restrictions. Please remind me to talk about the restrictions because I don't want to forget, okay? So, not right now. Wait till I'm done. Mr. Williams, don't forget the restrictions. So I have this monster of a rational expression. As you can see, it's just a fraction, right? There's some number in the numerator, some number in the denominator. But I want to simplify it. And the way I'm going to go about that is to break it up into its factors. Kind of like in the bell work, the 6. What did I do with the 6? I broke it up into 2 times 3, didn't I? I'm going to do the same thing here. So in the numerator, this is going to become, what is that, 2 times 5. 2 times 5 gives me 10, and then 2 plus 5 gives me the 7. If the factoring is what you're having trouble with, that's a different lesson altogether. You need to come get some help on that. We've done factoring. If you're hurting with it, you'll know today. And you'll have to come get some help, okay? And we all hurt, okay? Now the denominator that's going to break up into 5 and 2. 5 and 2. The 5 will be negative, the 2 will be positive. So I have this business going on. I've broken it up into its factors there. But then I can use some of these rules of fractions. Guys, what's 1 over 1? What's 2 over 2? What's 3 over 3? Pi over pi? So anything over itself is 1. This is x plus 2. This is x plus 2. X plus 2 over x plus 2 is 1. Okay? AKA, you guys remember what we did yesterday? AKA, let's talk about that top part, that restrictions. For starters, what can x not be? Down here. Well, we know the denominator can't be 0. That means that x cannot be a couple of things, right? It can't be 5 because if x was 5 here, 5 minus 5 makes 0, so it cannot be 5. And what else can it not be? It cannot be negative 2. Okay? But anyways, that's just a little side note, restrictions. We said that this and this make 1, so we're left with x plus 5 over x minus 5. And of course, x plus 5 over x minus 5 is simply that. Not 0, not 1, because they're not the same binomial. We don't know what those numbers are until we find out the value of x. But are we solving anything here? No. This is an expression, therefore it cannot be solved. It can be simplified, but not solved. Okay, just reminding you of that. But here's what we have. But again, even though it's simplified to this, what are the restrictions on it? X cannot be 5, and it cannot be negative 2, because you always have to think back to the original expression there. Okay? Now, I want you to make a supposition. If this actually said y equals, would this equation have discontinuity? It would? It would have discontinuity? Kaylee? Where would it be discontinuous? It would be discontinuous at 5? Where else? And negative 2. It would be discontinuous, Kaylee, where these become 0, which was what we said it cannot be. That would create discontinuity. That would break, if you will, it would break the math. And we would have undefined business here. And we can't have that. So we would have discontinuity at 5, and we would have discontinuity at negative 2. Now, magic question. How many different types of discontinuity are there? 2. Okay, there's 2 different types of discontinuity. There's removable discontinuity, and there is non-removable discontinuity.
How do you tell which is which?
Fantastic. That was my question. You beat me to it. How do I know which is which? Okay, so let's go back to here. And you might want to make a note, and if not, go back and listen to this recording again. I have this thing called removable discontinuity, and then I have the non-removable. So how do I know if it's removable? That's a result. That's a result. Because if you look at this, I don't see any holes there, do I? Okay, you guys ready? Do you see this x plus 2 in the denominator? Why don't I see it in the denominator here?
Because it canceled out.
It canceled out. And I'm throwing air quotes because did it really cancel? No, it made it 1. But it canceled out. It's gone. Therefore, what did I do? I removed it. Removable discontinuity. So if I can get it to cancel, and I hate saying that word because it's not true, but if I can get it to go away, that's not true either. If I can turn it into a 1, then it's gone. Okay? That's a removable discontinuity. Now make a note of this as well. If it is a removal discontinuity, in the graph, it should show up, it must show up as an open circle, as like a little hole there. And this is what I mean. Let's say you're graphing it. And where's that at 5? So let's say we're 1, 2, 3, 4, 5. I don't know. Maybe it's doing something like this. It's going to have a hole there at 5. Because guess what? We know from the original function that there's a problem when x is 5. Actually, no, that's not true. The removable one was at -2. At -2, not 5. So 1, 2. Sorry about that. And I should have been on the other side. Oh, Munoz, you dropped the ball. Discontinuity was at -2. So our hole should be over here somewhere at -2. God. God. Gosh. Oh my gosh. But that leaves that leaves the what decide what we want to say. That leaves other discontinuity in this problem though. We found that the x plus 2 binomial gave us removable discontinuity. Do we have some of the non-removable discontinuity? We do have non-removable discontinuity. Because remember, we said x can't be 5, right? We said x cannot be 5 either, and that's because this guy right here, this guy right here, this guy right there, if x is 5, that would become a 0. The entire binomial would become a 0, therefore breaking my problem once again. Now, when I look at that, that guy is in the denominator. So was I able to remove him? No, that is non-removable discontinuity. How will that affect my graph? Is it going to make another hole? No, this time it's going to make an asymptote. An asymptote. It's an asymptote. That is an imaginary line that never crosses. So let's say this was my grid. What was the asymptote at? 5? 1, 2, 3, 4, 5. And I'm going to draw it like this broken line. But that broken line is not really there. It's just kind of a visual thing for me to see that it's going to get closer to that area, that section, but it's never going to touch it. Because it can never be 5. If it is, you've broken math. Well, you haven't broken it, you just have too many choices. So we say undefined. Okay? All right, cool. Are we good here? Here's another example I want to show you. This has no factoring in it at all. Don't have to factor nothing. You ain't got to factor nothing. But I still want to simplify it. And I'm going to use the same old rules that I've been using. Now you'll see that the rules of division are involved and the properties of exponents are involved. You guys ready? I don't see all the eyes yet. If you have something like this, notice there's no parentheses, there's no factoring involved. It's just an expression. I'm going to worry about my integers first. What quotient is that? Huh? What is 24 divided by a -6? -4. So? -4. Ah, yeah. I like this a lot too. Now, I'm going to look at the x values. Oh, x to the third over x to the second. That means that these two are going to cancel 2 of these and leave me with 1x on top. Do you see it? And as I look at the y's, what's going to happen there? The 2 on top are going to cancel 2 of the ones on the bottom and leave me with 1y in the bottom. And math. I'm done. I would ask you for a thumbs up, thumbs down, but I took my glasses off and I can't see.
It's a stroke.
All right, show me those thumbs.
Wait, thumbs or fingers?
I'm like here.
Thumbs. Thumbs up, thumbs down. You right here? You want to see it a little bit differently?
Yes.
Here, I could do that. I'm trained for this.
Wait.
Here, I'll write it over here. It was negative 4x over y.
I'd like to see what it looks like.
Okay, so what I'm really doing is I'm going to break this expression down into all of its prime values. 24 is 2 times 2 times what? Times 2 times 3, correct? So if I did upside down cake with 24, I would get 2, 2, 2, 3, correct? 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. And then I've got x, 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 y, y, correct? And at the bottom, I've got negative 2 times 2, x, x, y, y, y. And then guess what I do? I have a heyday with the anything over itself is 1 rule. So that means that this is 1, this is 1, this is 1,
Oh, whoa.
this is 1, this is 1. What else?
One more x.
Oh, what?
Oh, I'm missing something. My bad. I didn't factor this one right. So let me undo all this. I apologize. 2 times, that should be 2 times 3, so negative 2. Oh, I don't want that color. I don't want that color. 6 is 2 times 3. It's not a 4. What am I thinking? And then I've got 2 x's and I've got 3 y's. Okay? That's correct. Thank you. Thanks for sharing something right there. So, 2 over 2 is 1. 3 over 3 is 1. X over x is 1. There's another 1. There's another 1. There's another 1. So what is 1 times 1 times 1 times 1 times 1 times 1? 1. So what do I have up here? I've got 4.
Oh, you should have left it.
Pretty fancy, wasn't it? So I have that guy left over, and I've got an x left over. And then in the bottom, I've got a negative, and I've got a y left over. So there it is. But I don't want to put that negative down the bottom. You could kick it to the front. That's probably the better of the two. So it'd be like 4x. So it'd be something like this. That would probably be the better of the two. But whatever. I mean, the first one's not wrong. The second one's not wrong. Even if I kicked it to the top like I had originally up there, it's still not wrong.
Will math excel accept it?
It should, and if it doesn't, then I'm going to laugh at Math Excel. Because you can't tell the difference. Hi, God. Thumbs? Ah, I like it. Moving on up. Anybody still writing? Moving on. It's time to do some math. It's time to do some math. These are the operations I like. I like multiplying. Do you like multiplying, good folks?
Yeah, I'd rather
I'd rather multiply too. So, check this out. Do you guys remember how we multiplied fractions? Like if I had 2/3 times 1/5, what did you do? Yeah, you just went straight across. So technically this was 2 times 1 over 3 times 5, which became 2/15. Math. Actually, arithmetic. Right? Arithmetic. 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 That's why I like this. Do not listen to that alarm. Today is a short day. So, you guys ready to see what this looks like? Commentate, commentate, commentate. If you have a problem with this one, it's probably going to be the factoring. Let me tell you why. Okay? Watch. I'm just going to factor this. I'm just going to show you what I like to do. I like to kind of do like a, I start here and I kind of do this business. Okay? Here, let me show you what I mean. I start with this one, I start numerator. So this becomes 2 and 3. That's a positive, that's a negative, correct? Correct me if I'm wrong. I just factored that numerator. We're good?
That's for 6, right?
That's for this part right here. I shouldn't put a dot there, but that's that one. Now, the bottom one, well, that just is. There's not much I can do there. So that's done. Okay? Yeah, yeah?
What about the other x?
What other x?
So x plus x? Wouldn't there be an x on the outside of the parentheses?
What are we talking about?
See how it's x squared? Wouldn't it be x times x minus 2? And then
Oh, I've got two binomials. If I was going to FOIL this, what is x times x?
check
What about the other x on the other parentheses?
Which one?
The one you circled, the 3 x's.
This one? Oh, that's a factoring thing. You need to come see me. Let me do this real quick, okay? Let me just show you. What is x times x? X squared. What is x times 3? That is 3x. What is negative 2 times x? That is negative 2x. So what is 3 minus 2 x's? And then what is negative 2 times 3? Okay, that's a factoring thing. Did I not just say that? Okay, so if you don't remember that, shame on you. But then come back to tutoring, and we will review that, and I will help you, and you will be good to. You stay. You will be. You'll be good to go. Okay. Now. Oh, cover. Let's move on to the other side. This is the difference of squares. That means when I factor it, I'm going to get these things called conjugates. You guys remember those conjugates? That means x plus 5 and x minus 5. That's an ugly x, but there it is. Oh, I'm just going to fix that. That's horrible. X minus 5. Okay? And in the denominator, it looks like I'm going to have an x plus 1 and an x plus 3. Yeah? Yeah, yeah, yeah? Cool. Now, here's the beauty. This is multiplying two fractions. What do? Multiply straight across. So that means that everything that's in the top, guess what? Stays on the top. And everything on the bottom stays on the bottom. Yeah? Let me tell you a secret. Can you hear me? At this point, I'm going to use my anything over itself rule. Yeah, exactly. Anything over itself rule. So x minus 5 and x minus 5 is how much? 1. Bye. And x plus 3 and x plus 3 is 1. Bye. So now, all I've got is x minus 2 times the x plus 5 over x plus 1. Arithmetic.
Oh, sorry.
What did you say? I've been so careful with that. I know, I dropped it. Yes, let me do that real quick. Boom, there it is. You know what I'm going to try to do? Ooh, it did work. Smart board. If you're going to say cancel out, throw up those air quotes, okay? Cancel out.
Sorry. Would you like to simplify?
You're allowed to, as long as you do that, and then all is forgiven.
Okay.
What's up?
Would you have to simplify the x minus 2 and x plus 5?
No, that is simplified.
I mean, like, FOIL it?
That's a fantastic question. If they tell you to simplify, what I've got at the end is simplified. If you go over and you start to FOIL out, that's not.
That's just rewriting it back.
Yeah, you're just. Yeah, there's no need to. Don't do that. Okay. But I do want to point this out though. Math Excel is picky. I think you've noticed, right?
Yeah.
Like, MathXL has a temper. I don't want that. I said the third decimal place. Read the instructions, please, carefully. Because it might want that they want the numerator expanded and not the denominator, or the denominator expanded and not the numerator, or maybe both expanded, or maybe neither expanded. I know. It hurts my head too. So just be careful with what MathXL is telling you to do. That's all. And then math is fun. And all is well.
But it gives people headaches.
It's not a headache. That's your brain getting muscular and learning. You know, like when you lift weights and you're sore, it's not your muscles hurting, it's you're getting stronger. So if your head hurts, it's not a headache. It's your brain getting stronger. She's looking at me like, I don't believe that at all. Can I change the slide? No? Okay, I can have more of my job.
I got it. Right here.
Uh-huh.
The one in red is the answer?
The what?
One in red.
What did we answer?
Okay, so it's not you just said no.
No, because I want you to remember what I said about that. Do you remember what I said? When can we answer something? There was no question. There's no equal sign either, is there? All we can do here is simplify. So that is, and I'm going to throw some air quotes for you. This is what you're looking for as what you would call the answer. But all I've done is simplified this. I didn't answer anything. I still don't know what x is. So I didn't answer anything.
Was it though?
That is the simplification, yes.
Why did you say it like that?
It sounded good. That is a simplification. That is a simplified form of these two rational exponents being multiplied. That is the product of these two rational expressions. Yeah. Are we good? Can I change the slide? All right, moving on. How about I just fly through this one, or do you guys want to try this one? I'll give you guys a couple minutes.
Yeah, please.
Fly through it.
Give you guys 2 minutes, then I'm going to call somebody.
I'll just wait till you pass someone because I don't want
You might be the one that gets called on.
You know if I can call?
And you know, people that say that, usually you end up being the volunteer. So please don't automatically volunteer.
Do you factor the bottom of the
Yeah, factor all of it as much as you can. What type of factoring is in the upper right-hand corner? Sorry, upper left-hand corner. What type of factoring is that? Upper left-hand corner, the 2x minus 8. That can be factored, right? What type of factoring? It's called a common factor. Common factor.
Should be x minus 4.
Yeah, exactly. You dropped your earbuds, bud. I know this is someone. You're cursed? Oh.
So, like, if I didn't know anything about this and I was just, like, looking at it, I would think at least in the second one that you could, like, cancel out and, like, couldn't you just subtract the
by subtract.
You know how when you say like fractions or like it's inverse, not inverse. When you have a fraction you're trying to multiply, sometimes you subtract it and you multiply and add. Because I'm trying to make it easier.
We're making it way harder. One over one. That's the difference of squares. So you have an x plus 4 and an x minus 4. We get 5. What? Oh no, I have It's time!
Oh, jeez.
Question goes to Stephanie Crockett. Haven't finished it? One more minute? I'm sorry, I don't have a minute to give. Does somebody have it completed already? What'd you guys come up with? X plus 1 over x plus 4?
Yeah. Or x plus 4 squared is 2.
That?
Yes.
And then with the 2 in the front. At the top. Like,
Yeah, that's what I had.
yeah.
That?
I said x plus 1 over x plus 4 times x plus 4.
You actually had this, but you missed something. So we'll talk about that, okay? All right, let's see. You guys ready?
So is that the answer?
I don't know. Let's find out. So here we go. Up here, I'm going to factor out the 2 because that is common to both of those. In the denominator, I've got the conjugates. You see what you did there? I've got x minus 4 and x plus 4. And I'm going to multiply that by, let's see here, this is going to factor into a 1 and a plus 4, correct? And then the denominator of that one will factor to be 4 times 4. So both positives in this case. So at this point, I know that I don't really need this times in there because everything is going to end up being just one fraction with everything on top and the other fraction with everything on the bottom, right? Sorry, with the denominator with everything on the bottom. Yeah? Are we good at this point? What do we do at this point? Yeah! Cancel! Air quotes. So, this is a 1. This is a 1. Huh? That's it? Okay. So, what's left up top? I've got a 2 with a plus 1. And I've got x plus 4 twice. I can write it as x plus 4 twice. So, yes, y'all was right. Y'all's.
My parents said they were here to drop something off with me at 11:30.
Yeah, go ahead. I don't see anything here, but you'll watch the video if you need to. Your confusion? Where? Everywhere? What?
I guess I forgot some stuff.
Okay, so then we need to do some factoring business. Okay? All right.
Yeah.
Come- This one?
No, another one.
All right, I'm going to skip over to here. Yes,
Not yet.
I must
Yeah.
because of time issues.
We only have
I
to-
try to.
Can we just
Everybody commentate. Everybody commentate. I was going to do multiplication and then division tomorrow, but I can't separate the homework questions. So I have to do division, but you will be okay.
Wait.
Sorry, I'm getting excited, huh? Okay. Do not panic, my friends. Well, we're going to do another one, just for you. But first, division.
Wait, what is this called? Division what?
This is dividing the polynomials.
dividing rational?
Sorry, you're correct. I am incorrect. We are dividing rational expressions.
Mr. Munoz, you have the best vocabulary of any teacher that I've ever heard speak.
Oh, thanks. And I'm still learning my English.
Like, even like, she said stupid the other day. I should not use that.
No.
I'm like, you should have at least said like ignorant or something.
Lack of education, son.
Right.
You are lacking in the education. All right. Guys, even though we're doing division, it's not any harder than what you've already did. Sorry, that didn't sound right at all. Yeah, you just commented on how well I spoke English. It's not any more difficult than we've already done. This is why. If I was going to take 2/3 and divide it by, I don't know, 1/5, do I really divide by fractions? No. What do? We multiply by the reciprocal. Guess what? There's a lesson on division. Instead of doing this, what we're going to do is we're going to do this. And that's it. So big wow, right? So instead of doing this problem, what we're really going to do is 2 minus x, x squared plus 2x plus 1 times x squared minus 1 over x squared plus 3x minus 10. And there's your division lesson.
What?
Just make sure that you flip the second side.
Wait, only the second side?
Yes, you only flip the right side.
We don't got factor or anything?
And you change your division to multiplication.
Is
So
there
that's
ever
what-
a time where we get to choose which side?
No, never.
Always right.
Always right. Right?
And then we just
Right.
Wait, we don't have to
And then we just
factor.
do in the last.
Well, we would factor it. But I'm saying it's not any different than what we have already done. The only thing, the difference was it started with division, and in order to divide, we actually multiplied by the reciprocal of what's supposed to be the denominator. Let me show you what you would do if you stack them. If these were stacked like this, like let's say you had the 2/3 divided by 4/5. Okay, same idea. You would multiply by the reciprocal of the bottom. So it becomes 5/4. That's the other scenario. That's all. But it's exactly what we did already. Okay? So here we go. Here's the problem. So we're doing it again. Ready, Delilah? I don't really like this 2 minus x business. I'm going to show you a couple of changes I'm going to make to this so that you can see where they came from. If I rewrite it, it's this. Right? I don't want that negative there. So I'm going to call this instead, I'm going to factor out a negative, and it's going to become negative x plus 2. Okay? No, minus 2. Because negative makes it positive again. Okay? So now I'm going to factor this piece, which is a 1, 1, and they're both positives. That is the difference of squares, so I'm going to get a conjugate of x plus 1, and then an x minus 1. Over on this side, I'm going to get a 5 and a 2, with the 5 being positive and the 2 being negative. Okay? And then start simplifying. X minus 2, x minus 2. X plus 1, x plus 1. What happened? Yeah. No. Because even if here's what would happen anyway, Dylan. If I multiplied it, this would end up being just one fraction, and it would just be anything over itself. And I just skipped that step because I want to save some time here. Okay? So I've simplified all of that. Anything else? Am I missing anything?
So it would just come out to negative x minus 1 over x.
So I would get negative x minus 1 over x plus 1. Oh, wait a minute. But isn't negative a positive?
But you have the x plus 5.
Yeah, but should we get rid of the... Thank you. Should we get rid of this combination here? No, they're not the same. Because if I follow that negative, it would become negative x plus 1.
Wait, where did you get that?
Where did I get the negative? Let me show you, okay? and it came from here. What I did, and I'm going to put it here in blue so you can see it, I swapped the order. That's okay, right? I can do this.
Yeah.
But then I don't want x to be negative, so I factored it out. So that made it a positive x. But by doing that, that changes the sign of the 2 as well.
So the negative is just standing alone?
Yeah, it's technically a -1, but we don't have to write it unless you want to. Okay. Guys, that's all I've got today. Thank you very much. If you need to go back and watch some of this stuff again, it should be on the tube of you.